Okay, we are trying to find the antilogarithm using logarithm table. Our logarithm table can as well be used to find the antilogarithm of a number. For example, now we are given these three questions here. Find the antilogarithm of 0.7597, antilog of 2.5463, and the antilogarithm of negative 2.0258. So we are going to look at each of these questions and we are going to do it. So when we are asked to find the antilogarithm, this is our solution of number 1. Antilogarithm, it means the question is like this: logarithm of a certain number equal to this 0.7597. This is what it means. Okay, this is what reflects here, right? So if that is the case, then it means that we are finding the number whose logarithm is this one here. We are finding the number whose logarithm is 0.7597. Okay, so we go back to our logarithm table and see how we can get this number here. So this is our logarithm table. As you see here, it is a logarithm table, and we use this logarithm table to find the antilogarithm. So when we use logarithm table to find the antilogarithm, it means that we are going to look from inside towards outside. We are not going to look from outside towards inside. Now we look from inside towards outside. Our number is 7597. So we are going to look this mantissa from inside of the logarithm table and see what number outside corresponds to it. So we look that we look 7597, 7597, 7597. You look inside. So you see here we have up to 4. You move outside in this row, you find that you have 57. Okay, so you write somewhere here 57. Okay, this will be equal to 57. So antilog log 7597 equal to 57. Not yet done. Okay, equal to 57. Under this column here, it is under 5. So it is 57, then under 5. So we finish by writing this 5 here where we found it. So it is under 5. So we obtained this on 57 under 5. So we finish by writing 5 here. There is another 5 here. Okay, but now this is our characteristic. Okay, and mind you, to get this logarithm, the number was written in standard form. So we are going to write this in standard form. It is the same as 5.75 times 10 power this characteristic, which is 0. But we know that 10 power 0 is 1. So we say that antilog 5.75 times, the antilog of 0.7597 is the same as 5.75. This is the number which we are looking for, 5.75. That is the antilog of this logarithm here. This is our B. We have to look for antilog of 2.5463. So as usual, we know that this is our characteristic. Okay, So it is our characteristic. So we leave it and we deal with the mantissa. Okay. So from this mantissa, go to your logarithm table, right? Inside the logarithm table, as usual, the logarithm table 3 is between 54.53 and 54.65. So it is between here, right? So we pick this one, which seems to be much closer. So we are going to pick this one here. Mind you, that is not exact. So we have an extra of 2 points here. But we pick this. So we pick this and we read out. Outside we have 35 and we have the under. This is 0, 1, 2. So that it will be under 2. The under 0, 1, 2. So it is under 0, 1, 2. It is under 2. So it is 35, 2. 35. So this is equal to 35, 2. 2 is the same as 2, 0. Now mind you that 0. Now mind you that as from here you see this is 54.65 while we are looking for 54.63. So there is an increment of 2 which we have to minus in our mean difference. So you look the mean difference of 2. Where will it coincide? 2, 0, 1, 2. 2 falls into, so that is 2. This is 1, 2. Falls into 2. So we have this difference, mean difference of 2, which you have to take away. So you come here and you take away 2. Take away. You get 8. So this is what you get. Now, we change this into standard form, this number into standard form. This is the same as 3 standard form. This is the same as 3.518, then times integrals of the characteristic. Okay, the characteristic was 2, so it is times 10 power 2. So, and now we finish that antilog of 2.5463 is equal to, okay, this will be 35, we will travel 1, 2 to land here, 35, 1.8, this is the number. This is the number which gave this logarithm. And okay, now this is our last example here, which is to find the antilogarithm of minus 2. Now you see this is negative 2. Negative 2, which means this number is below 0, because we know that logarithm of 1 equal to 0 and logarithm of 10 equal to 1 and base 10. So when we have a negative number, it means the logarithm of this number is below 0. It will be 0 point something. And when we are given in this case now, if we are given in this case, that means since the given number is negative, we have to make the mantissa to be positive. So because the logarithm table cannot read it, cannot give us any value of negative mantissa. So mantissa should be positive. So everything here is negative. So we have to make the mantissa positive and the characteristic to remain to be negative. That negative 2.0258 is the same as negative 3. We go down one step. From negative 2 we are going to negative 3. So negative 3 plus 3 will give you 0. In fact, this thing here is equal to 0. So there is no difference because it is still negative 2.0258. So these things here are done to go to our point of bar. So this negative 3 here is the same as bar 3. Now plus you do the addition of 3. You now perform 3. You will perform 3.0000, then minus 2.0 258 to make the mantis a positive, and this will give you 2. 9 minus 5 is 4, 9 minus 2 is 7, and we have 9 here, then we have 0. It will give you this, but you have bar 3 behind because this is given by these two, this one to this one. So you have bar 3 behind here. So this is how we make the mantis a positive. Now we have made the mantis a positive. Now the process will go the same way we did other two. We are going to have this, that this is now what we have as bar 3.9742. So you will use your 4 figure to look at it, because this is your characteristic and this is the mantis. So now you will use a 4 figure to read this, to find inside 97 under 3 and 97 under 4, 9742. 9742